What is the best language for data science, Python or R? This is a question many beginners ask themselves when they decide to venture into the world of data. It's a confusing fork in the road that seems to demand a definitive choice right at the start. You can learn either language and find success, but your choice can shape your learning path, the projects you'll tackle, and the career opportunities available to you. This guide will demystify that decision. It gives a clear, straightforward explanation of both languages so you can make an informed choice that fits your goals. We won't declare one language universally superior. That would ignore both their strengths. Instead, we'll provide clarity. We'll show Python through simple examples. We'll do the same for R, highlighting what it does best. By the end, you'll have a framework to choose the best starting language for your goals. At its heart, Python is a general-purpose programming language. It was designed to be versatile, well beyond data analysis alone, building websites, creating applications, and automating tasks. Its philosophy emphasizes readability and a clean, straightforward syntax. Within data science, Python has become a dominant force. Pandas for data manipulation, scikit-learn for machine learning, and matplotlib for creating charts and graphs. In contrast, R was created by statisticians, for statisticians. It was built for sophisticated statistical analysis and data visualization. Many of its core structures and syntax are optimized for analyst operations. R excels at statistical modeling, data exploration, and producing publication-quality graphics. Its ecosystem is anchored by the tidyverse for importing, tidying, modeling, and communicating results. Think Python as a comprehensive multi-tool and R as a precision instrument. Python shines when analysis must integrate into software and deployment. For many beginners, the ease of learning a language's syntax is a critical factor. Python is praised for readability that often resembles plain English, with uncluttered, intuitive code. Basic operations are straightforward and memorable, using simple keywords. A newcomer can often grasp what a simple script is doing at a glance. R's syntax can present a steeper curve, especially for true novices. You'll see unique operators like the assignment arrow and the pipe used extensively to chain commands. The pipe represents a different way to think about data flow, step by step. Ease isn't just syntax. With the tidyverse, R makes practical data tasks fast through a consistent grammar across packages. That cohesion can make beginners productive quickly, often faster than mixing Python libraries. If you have coding experience, Python will feel familiar. If you're new and analysis-focused, R might yield quicker wins after the initial hurdle. Different philosophies. Python offers a gentle, general-purpose on-ramp. R offers a specialized, faster path to practical analysis. The toolkit, libraries and packages for data work. Python's ecosystem is extensive and mature, covering every stage of the data science workflow. For tabular data, Pandas is the standard, cleaning, transforming, and analyzing with data frames. NumPy delivers efficient arrays and math functions. Scikit-learn provides algorithms for classification, regression, and clustering with a consistent interface. For deep learning, Python leads with TensorFlow and PyTorch. R's ecosystem is equally impressive, focused on statistics and visualization, anchored by the tidyverse. These packages are designed to work together with a consistent grammar. Beyond tidyverse, CRAN hosts thousands of packages covering techniques from time series to bioinformatics. Shiny makes interactive analysis apps straightforward. Python's toolkit favors performance and production integration. R's toolkit is optimized for analysis, reporting, and storytelling. Real-world scenarios and a sales example. Let's analyze a small monthly sales table with month, product, and sales, and total sales per month. In Python, you'd use Pandas. Load data into a data frame, group by month, then apply sum to compute totals. Clear, explicit, step by step. In R with dplyr, load into a tibble and use a pipe chain. Take the data, group by month, then summarize with the sales sum. Expressive and efficient for exploratory work. Now, a quick visualization. With Seaborn, call lineplot and add a title and labels for polish. With ggplot2, define aesthetics and add geom line. Strong defaults yield publication-ready charts quickly. The strength of a language is also its community and the opportunities around it. Bigger communities mean more tutorials, books, documentation, and faster help. Python's community is enormous and diverse beyond data science. That scale translates into abundant learning resources. R's community is smaller but highly focused, collaborative, and supportive in statistics and analysis. Job boards typically list more data roles requiring Python, reflecting its dominance in production environments. Companies building ML features and deploying at scale lean on Python. R roles cluster in academia, government, healthcare, pharma, and finance. Great fits for statisticians and researchers. Python opens broader tech roles. R aligns with statistically intensive careers. If your goals are deeply statistical or research-driven, R can be a direct path to rewarding work. After comparing philosophies, syntax, toolkits, and job prospects, here is the recommendation. For most beginners today, Python is the most practical and strategic first choice. Its gentle curve, general-purpose nature, and massive community provide a flexible foundation. Python unlocks analysis, ML engineering, web integration, and software development. This does not diminish R. There are scenarios where starting with R is better. Choose R if your primary focus is academic research, deep statistical analysis, public health, or ecology. Python pros: easy to read syntax, versatile across web, apps, and data, huge job market, deep learning standard. Cons: sometimes more code for stats, default plots less polished. R pros: excellent for statistical analysis and visualization, expressive tidyverse grammar, great reporting with R Markdown. Cons: less common in production software, smaller job market, syntax can feel unusual. The choice isn't permanent. Learning one makes the other easier. The most important step is to begin a small project that interests you. Clean it, calculate basic stats, and visualize.